Hello everyone, my name is Dr. Asan Kumar. I am Assistant Professor in the Department of Electronics and Communication Engineering, SR University, Warangal, Telangana. So, so let us talk, continue my lecture for regarding a special diode. So already I cover Vector diode. It's a type of a special diode. Tunnel diode is heavily doped diode used in microwave application. Another LEDs, light emitting diode and photodiodes. So this thing completed in my previous lecture. Now I am discuss about the laser. Laser is a very important. So laser is full form is light amplification by stimulated emission of radiation. So a laser is a device that produce a highly intense monochromatic coherent and directional beam of the light. So, so basic idea of a laser, it like ordinary light sources like bulb, ordinary light is spread in all directional. It contains many wavelengths. It is not a coherent, but laser light is a monochromatic and single wavelength. It is a coherent wave in phase. So highly directional and very intense. So basic principle of laser, let us work on three important processes. First one is absorption, second one is spontaneous emission, and third one is stimulated emission. So let us understand these things one by one. So absorption means when a electron in a atom absorb the energy, it's move from lower energy level to higher energy level. So this higher state is called the excited state. Means another thing is spontaneous emission. After short time, the excited electron return to the ground state. So it's emit a photon randomly. So that emitted light is not a coherent. This is happen in a ordinary light source. But stimulated emission is a most important if an external photon of correct energy strike an excited atom, the atom release another photon. Both photons have same frequency and same phase and same direction. This process is called stimulated emission, and this is a basic principle behind the laser operation. Next is population inversion. Normally, more atoms are in ground state and very few atoms are in excited state. But for a laser action, the number of atoms in excited state must be greater than ground state. This condition is called population inversions. Population inversion is achieved using external energy supply called pumping energy. So main component of the laser, a laser system has three main parts. Active medium means gain medium, pumping source, optical resonators, and active medium material where simulated emission occur. Example, ruby crystal, helium, neon gas, semiconductor material. Ruby crystal, helium neon gas, and semiconductor material. Pumping process provide energy to create the population inversion. Example, flash lamp, electrical discharge, and electric current. Optical resonator consists two mirrors. Optical resonator consists of two mirrors, only fully reflected mirror and one is partially reflected mirror. So light bounce back and forth, get amplified and emerge a laser beam. So type of laser, solid state laser, that is ruby laser, gas laser, that is He laser, helium neon laser, and semiconductor laser, and fiber lasers. So properties of light: highly monochromatic, highly directional, high intensity, and coherent. So this is a powerful properties of the laser. So next, so symbol of laser, it's look like a, see in that figure, and left side is denoted by anode and right side pin is denoted by cathode, means that positive and negatives. Now construction of laser. A laser diode is made for direct bandgap semiconductor materials such as gallium arsenide, aluminum gallium arsenide, and gallium phosphide, indium phosphide. These materials are chosen because they efficiently produce light through electron-hole recombination. So main part of the laser diode construction, that construction mainly consists of p-type semiconductor layer and next n-type semiconductor layer. So in this picture we can see the p-type material is a green color and n-type material is pink color, and in between p-type n-type one inversion layer, it is denoted in blue colors. So that blue color active region, an optical cavity resonator reflecting surface in the top of the surface in and metal contacts is front and back side. There are two contacts, front side and back side. One is anode, another is cathode, which is reflected in previous slide symbols. So that laser is normal like a normal diode, a laser diode has a p-type layer and n-type layer. Means when forward bias electron move from N to P, means that N-type layer to P-type layer. Holes move from P to N, means P-type semiconductor layer to N-type semiconductor layer. So recombination occur at the junction. So in that junction, we can see in this picture arrow marks. So that is the junction point. So the active region, the region near the junction where recombination occurs, so is called the active region. Means that in that wave region is shows like blue color, the active region shown in the picture in blue colors. Next, the region is very thin, means that active layer is very thin, and this layer is designed carefully. So that layer is responsible for light generation in modern laser diode. A double heterojunction structure is used. Means that heterostructure improve the efficiency of the laser, and double heterostructure in a practical laser, a thin layer of low band gap material is sandwiched between two high band gap material. This structure conforms both charge carrier light wave. This increases efficiency and output power of the laser. So optical resonator cavities, the two ends of the semiconductor crystal are cut and polished to from parallel reflecting surface. One surface is fully reflecting, the other surface is partially reflective, and these two surfaces from optical cavities, light generated inside the active region reflect back and forth between the mirrors, get amplified, and finally comes out through the partially reflecting surface. So then metal context. Coming to the last point of the construction, metal contact are provided on the top of and bottom of the surface. That metal contact may be aluminum, may be silver, may be gold materials. To apply forward bias voltage, to inject the current into the junction. So packaging of the laser diode is enclosed in a protective metal or plastics, causing a transparent window or lens. Means sorry for that. casing the transparent window or lens, sometimes a heat sink to remove excess heat. So the important feature of construction, a very thin active region, high polish parallel surface, direct band gap material, current injection mechanism, and optical feedback system. So this is all about for construction. And coming to the working, a laser diode is a semiconductor device produce coherent monochromatic and highly directional light. It works on the principle of stimulated emission population inversion. So basic operating condition, a laser diode operated in forward bias condition. When forward voltage is applied, the P region is connected to the positive terminal of the battery and N region connected to the negative terminal of the battery. So electrons are injected from N region to P regions. Holes are injected from P to P region to N region. So both charge carrier meet in the active region near the junction. So 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 that light are emitting is a highly directional. Now, so let us understand about working in step by step. Carrier injection means when sufficient forward current is applied, a large number of electrons enter in the active region. So a large number of holes also enter the same region. Means at the junction, a number of electrons, a number of holes enter that region. So recombination become beginning. What happen after entering the large number of electrons and holes, then recombination starts. Spontaneous emission, some electron recombine but with hole, but photon are emitted randomly after accumulated the electron holes that are recombined and with hole and photons are emitted randomly. This is a similar to LED operation. Population inversion, as the forward current increases beyond a certain value called the threshold current, more electrons occupy higher energy level. So number of electron is excited state becomes greater ground states. This condition is called population inversion. So population inversion is essential for laser for action and stimulated emission. Now when a photon passes through the active region, it is stimulated and excited electron. These electrons release additional photon. The new photons have same frequency, same phase and same direction. So this process is called stimulated emission. Because of this, light get amplified, and optical feedback, that two parallel reflecting surface of the diode act as a mirror, that photon reflected back and forth. The light intensity increases only photon moving parallel to the x-axis. Finally, a strong coherent laser beam comes out through the partially reflecting surface. So laser action starts only when the forward current exceeds a minimum value. This value is called threshold current. Below threshold current, device behave like a LED, and above the threshold current, the device work on a lasers. So important characteristics: operate in forward bias, require threshold current, and produce coherent light and very high intensity. Next is uh, so a laser emits a beam of electromagnetic radiation that is coherent in nature. This means the light wave produced are in the same phase, have at same frequency, and travel in the same direction. This is a working of laser based on their very important process. Next is, in that figure we can see absorption. An electron present in lower energy absorber energy level, that is observed energy, when sufficient energy is supplied, usually by applying voltage, the electron jump to the higher energy level. This higher energy level is called excited state. In this diagram, we can see a photon with energy h nu striking the electron and pushing it is the upper levels. In the first step in a laser operations. Next figure is spontaneous. The excited electron does not remain in the higher energy state for long. It naturally return to the lower energy level. During this transition, it emits a photons of energy equal to the energy difference between the two levels. However, this emitted photon has random direction and random phase. This type of emission is not coherent. It is similar to the light producing in an ordinary LED or bulbs. But stimulated emission, this is a most important process reflected in the figure. So, the stimulated an excited electron is struck by an incoming photons of the same energy. These incoming photons stimulated the electron to return to the lower energy level. During this transition, the electron emits another photon. The key point is both photons are identical. They have same frequency, same phase, and same direction. and same wavelength. Because of this, the light is amplification occur. This process produce coherent radiation, which is main characteristics of laser light. So next is energy band gap explanation. So we are understanding the energy band behavior of a PN junction diode laser under different biasing conditions. The diagram shows how the energy level changes from zero bias to forward bias and finally to laser action. So first is at zero bias condition, the Fermi level represent as a EF remains uniform and continuous across both P side and N side. There is a external voltage applied. The conduction band and valence band bend near the junction due to the built-in potential. You can see in that the picture that valence band and banded near the junction. No external current flows so that at a equilibrium the system is stable and there is no light emission in first energy band diagram. Next is when forward bias is applied. Now when forward voltage, that is denoted by Vf, the P side energy level shifted downwards related to N side and the Fermi level splitted in two separate levels, that is EFN for electron and EFP for Fermi level of P for holes. The difference between these two quasi-Fermi level becomes equal electron where apply voltage. Because of this, the barrier potential reduce and electron from inside move towards the junction and hole from P side moves towards the junction. In the third figure, for higher biasing, forward biasing condition, when applied voltage increase further, a large number of electrons fill the conduction band. In the junction region, a large number of holes occupy at the valence band. This carrier concentration become very high. Now population inversion occur. The separation between quasi-Fermi level becomes higher and greater than band gap energy. At this stage, electron holes recombine take place, photon with energy or h nu are emitted and stimulated emission beginning. The laser action occur in the transition region. This region show between the dashed line is called the active transition laser in the last energy band diagram where light generation happen. So next is uh, the energy band frequency condition in the PN junction laser. First is minimum frequency emitted. Photon is determined by the band gap energy. So it is given by the relation energy photon is nothing but it is a ratio of energy upon Planck's constant. So this indicate the energy difference between electron and holes in quasi-Fermi level must be sufficient to support the photon emission. Finally, combining both conditions, we get operating condition of the PN junction laser. and this is the key condition of the laser action. So the photon energy is larger and enough to overcome the band gap, and carrier injection is strong to maintain the population inversion. So next is uh, characteristics of lasers. First, let us understand the threshold voltage. At a lower energy level, the emission is weak because of only a spontaneous emission occur. This means the light output is very small and not coherent. Now, we increase the input current, the diode approach a critical point is called the threshold value. At this point, optical gain becomes equal to the internal loss of the system. Once the current exceeds this threshold, laser actions. We can see in that picture. So after this voltage, power rises sharply and indicate efficient laser operation. In this graph we can see that after this pole voltage, that current power is increasing sharply. Next is characteristics of lasers. The characteristics laser diode terms of current and spectral behavior. This is a spectral behavior by voltage versus power. Let us start below the threshold region when injection current is less than threshold current. The carrier density is active region not sufficient to achieve the population inversion. Therefore, recombination occur mainly through the spontaneous emission. So that thing we can see that picture, and next is application of laser. So laser diode is various field of application. First is laser diode is widely used in fiber optical communication system due to high efficiency, compact size, and ability to produce coherent light. They are ideal source for transmitting the data over long distance with low loss and high speed. They are commonly used in optical transmitter in the internet and telecommunication networks, and it is also used to painkiller, and it is used in laser printer and CD writing regarding. So this is all about the laser, how what is the working, where application, construction. So thank you for watching my video. So next